Welcome to 15.4, Law of Sines. Number 1 says, use the diagram to the right and write expressions for h in terms of sine of 49 and the sine of 28. So when we look at the picture, triangle ABC, we have a right triangle on the left, and we also have a right triangle on the right. So 49 can be set up using sine because h is the opposite side length and 26 is the hypotenuse. So we can say the sine of 49 is h over 26. Similarly, we can also take the sine of 28 and say that it's equal to h over 41.8. If we rewrite each in terms of h, we would get 26 sine of 49, and we would get 41.8 times the sine of 28. Number 3 says solve for h. So in above, remember, you got to be in your calculator in degree mode. If we solve for h, we're going to get approximately 19.6. And over here, we're also going to get approximately 19.6. So if we think about what we did, we set up 26 sine of 49 was equal to 41.8 sine of 28. Well, what we could do is we could divide by different things and rewrite this alternatively. So that's what we're going to do. We're going to take the sine of 49. We're going to divide by 41.8 on both sides. And also we could take the sine of 28 and divide by 26 on both sides. So basically we have the same problem rewritten. Now what you'll notice there, when you look at that relationship, if you look at the big triangle above, triangle ABC, the sine of 49 in relationship to 41.8, which happens to be the side length opposite 49 degrees. Similarly, the sine of 28, if we look at the 28 degrees angle C, 26 is the side length opposite it. So we're saying those ratios are the same. So that brings up what's called the law of sines. So the law of sines says the sine of A over the side length opposite angle A is going to equal the sine of B over the opposite side B. And we could also include the third side. Basically, we could redraw these for other triangles and do it. We're not going to do it today. But we could basically, all three sides and three angles have the same relationships. So we use the law of sines for non-right triangles. For right triangles, we still would want to use SOHCAHTOA. So problems below, we're going to use the law of sines to solve the triangles. So in triangle ABC, A is 22, C is 34 degrees, and little a, which is the side length, is 7. I would encourage you to draw a picture, as I think it just helps you see what you're doing. So A is 22, C is 34, we have B, and this is 7. So very quickly, if we were solving the triangle, it means find all the angles and all the sides. The easiest thing to find right off the bat is to find angle B is 124, because we know three angles add up to 180 degrees in a triangle. Now from that information, we can set up some different equations using the law of sines. So we have the sine of 22 degrees over the side opposite, which is 7. That would equal the sine of 34 over C. Remember, little c would be the side opposite angle C. So to solve this, we can cross multiply. And then what we would do is we would divide by the sine of 22. So we're going to get C to come out to be about 10.4. Now what if we want to find little b, because it said solve the triangle? Well, we can certainly do that. We can use the sine of 22 again over 7 But now we have to set up the sine of 124 degrees, and the side opposite it, it's going to be little b. Again, we can cross multiply. And we can divide by the sine of 22. And we'll get b to be 15.5. So now we have solved the triangle because we found every side length and every angle measure. Number 5. Again, we have triangle ABC, but you'll notice that all 3 sides are given. So the problem before, we basically gave you 2 angles and a side. Now we're going to give you 3 sides. So if we draw this picture, if you were to try to use the law of sines, you would notice that you would get stuck because you would have the sine of A, for instance, over 9 equals the sine of B over 10. You have 2 variables. That's no good. So we're going to erase that. And we're going to start over. We're going to actually revert back to a previous lesson that said we're going to find angle C. And to do that, we're going to use the law of cosines, because we always want to find the largest angle possible. So this is where your reliance upon all the laws comes into effect. It's a side-side-side case. That's when we use law of cosines. So we get 121 equals 181 minus 180 cosine C. Remember, these are unlike terms on the right-hand side. So we actually have to subtract the 181 to the left-hand side. And we're going to get negative 60 equals negative 180 cosine C. Divide by 180, we get 1/3. Remember, then what we do is we do the inverse cosine, both sides. Those cancel. The inverse cosine gives us C to be 70.5 degrees. Now from here, we have C to be 70.5 degrees. We do not have to use the law of cosines anymore. We can actually now go to the law of sines. So we can say the sine of 70.5 over 11 equals the sine of B over 10. And I just tend to go in order so that geometrically, when I solve for B, I can kind of check to make sure that opposite the longest side is the biggest angle, etc. So to solve for this one, I'm going to multiply through by 10. So I'm going to take 10 times the sine of 70.5 over 11 equals the sine of B. There's no point in cross multiplying there because sine of B was basically what I needed to isolate. Once I get there, then I can do the inverse sine of the entire answer. Remember, you don't really have to write the inverse sine on both sides, but mathematically that's the best notation. And so I type all that in my calculator, and B comes out to be about 59 degrees. So once I get B to be 59 degrees, I can very quickly go and subtract and find A to be 50.5. So A is 50.5. All right, we have one last problem to do. John is building a triangular-shaped dog pen for his Chihuahua. The space allowed for a dog pen is restricted. One side must be 12 feet long, and another side must be 26 feet long. The angle opposite the 26 feet side must be 35 degrees. So if you draw this picture, we have 12 feet. We have 26 feet. And it says the angle opposite must be 35 degrees. So what must be the third side, and what are the other angles equal to? So when we set this up, we're going to have to use the law. Excuse me, the law of sines. So we're going to call this X, we'll call this Y, and we'll call this W, because that's basically, they're asking us to find everything. So the sine of 35 over 26 is equal to the sine of x over 12. Again, you don't need to cross multiply, just multiply through by 12. And then do the inverse. And so when you do that, you get 15.4 degrees. We can quickly find y by subtracting from 180. So we got 180 minus 35 minus 15.4. That comes out to be 129.6 degrees. And then the last problem that we need to do is find w. So we can do sine of 129.6 over w equals sine 35 over 26. So if we cross multiply and solve, w is going to be equal to 26 times the sine of 129.6 divided by sine of 35. So w is going to be approximately 34.9 feet. Good luck on your homework over 15-4.